All right, so this is going to be lesson 7.9, and we are factoring special polynomials. So if you take a quick look at your lesson 7.4 notes, okay, we learned about the special binomial products. So we took a problem similar to this, and we factored it out, or sorry, we didn't factor it out, we distributed it out, and then we found the product. So now we're going to learn how to do the reverse for both of these types. So let's do a quick refresher and say, well, what would you get if you had x plus 5 times x minus 5? Okay? So when we distribute this, we get x times x is x squared, x times negative 5 is negative 5x, 5 times x is positive 5x, and 5 times negative 5 is negative 25, okay? So x squared has no like terms. These are like terms, and remember how they cancel? So, and then we have negative 25, okay? So that's what that would be multiplying to. So we want to know how to go the other direction. So let's say we had, let's go with 36 x squared and minus 81, okay? So if we follow the same pattern, we know that these two middle terms are going to cancel, okay, because they have opposite signs. And if we look at the format of the two above, then we know that we're going to end up with parentheses like this. And if you remember how we've got opposite signs, okay, so we've got one positive, one negative. And we actually could just skip the multiplying of that and that, so that we just multiply the first times the first and the last times the last. So notice how this x and this x, it's the exact same thing, right? We have 5 and 5, just different signs. So we can basically say, well, what is the square root of this? Because we want to square root that. Well, that is 6x times 6x, so the square root would be 6x, okay? And then what times itself, or what's the square root of 81? Well, that's 9 times 9. So this would be the factored form of this. Now, this is a special type. This is called the difference of two squares, okay? So we can recognize it because when I'm looking at it in this form right here, so let me go ahead and erase the work that I did so you can see the original form, okay? The difference means that we are subtracting. Of 2, this is when we say, well, it's a binomial because there are two terms. And squares means that I can square root both of these because they are both perfect squares, okay? So let's practice one more. So let's say we have x squared minus 64, okay? Well, that would factor. Because my linear term disappears, I know I have opposite signs. So x times x is x squared. Square root of that is x. And square root of 64 is 8. Now, I can rewrite this so that it's x minus 8 and x plus 8. That's fine. Okay, let's do one example where the variable is actually second. So let's say we have 121 minus 4t squared. Actually, let's do 16t. Okay, so in this case, we do have the difference, and it's still a binomial, so 2, and they're still perfect squares. So even though the variable is second, it still fits the formula or the setup of difference of two squares. So if I square root this, I square root this, then I can say that it's the same as 11 plus 4t times 11 minus 4t. And that would be my factored form for this. Now, we also talked about these trinomials down here. So let's move this up a little bit. Okay. So now instead of having, you know what? Let's actually come back to this. So let's do an example where we have x plus 7 quantity squared. So that would be x plus 7 times x plus 7. So we get x times x is x squared plus 7x plus 7x plus 49. So in the previous examples, my linear terms had opposite signs, but here they don't. So they don't cancel. In fact, instead of eliminating themselves, I have two of the exact same thing. Okay, 7x and 7x. So it's essentially 2 times 7x. So I'm going to do that for just 1 second until we can see that this is like that, okay? And one thing that I want you to recognize is, well, x is the square root of that, and 7 is the square root of that, and we have 2 of them. So it's going to follow this form, and we get x squared plus 14x plus 49. Now it's easier to identify these because I have a leading coefficient of 1, okay? So if I square root this, then I get 7, and if I double it, then I get 14. So that's usually the general pattern, right? And then I need to also square root this, and I get x. So 7 times x times 2 is 14. So we can use that pattern to go in the reverse and factor out these examples. So we know that they're going to end up with this general shape, okay, when they have this pattern. Okay, and the way to see if it's true is check and see, okay, well, if I square root this, I get y, and if I square root this, I get a. And remember how I have 2 that are the exact same, so I have 2 of them? Well, then I get my middle term, so we're good. So the way that we come back to the factored form, okay, is by looking at the very first term, the last term, and then one more thing, the sign of the middle term, okay? So I'm going to say, okay, square root of this is y, square root of this is a, and my sign is positive, so that's my factored form. Let's try that one more time. Square root of this is 2j, so that's 2j. Square root of this is 9. Oh, that's a lie. Square root of 9 is not 9. Square root of 9 is 3. So 2j times 3 is 6j, and remember how we end up with 2 of them, so we multiply that again by 2, and we get negative 12j if we make that negative. Alright, so let's try this again. So we've got square root of that is x, square root of that is 4. That's the sign in the middle. Last one, we get n. And 9, we gotta match that sign, and we're done. Okay, so now let's try solving. So now we have to figure out what type is it, and how do we factor that, and then how do we use that to actually solve. So because this one is a binomial over here, so this one's the binomial, that one I'm going to remember factors so that it has opposite signs because we have to cancel out that middle term. Okay? So again, we square root both, so we get 9 and 9, and square root of that is 4t and 4t. Okay, so my first step was to factor that, and now let's factor this. So this one is going to follow the examples from previously. So square root of this is d, square root of this is 5, match that sign, and it's quantity squared equals 0. Now, to solve, we would square root both sides, and we would get d minus 5 equals 0, and add 5 to get d is 5. So we only have one answer. Over here, we use the zero product property and say that, well, if this times this equals 0, then both could be 0. And so we subtract 9, and we get this, and then divide by 4. So we have negative 9, 4 is t. And then if we subtract 9 over here, then we get negative 9, divide by negative 4. So then t is positive 9 fourths. So notice how for this example we end up with the same number, but we get both the positive and the negative. So I can write it like that, or I can box either one of these, but we end up with two answers, same number, but different signs. That's it for lesson 7.9. If you are ever stuck, you can still always go back and say, okay, if I want to factor this, then I can do it the same way of saying, okay, we need two numbers that multiply to this and add to that. So factors of 49 that add to 14, well, that's 7 and 7. So we get x plus 7 and x plus 7, which is the exact same thing as x plus 7 quantity squared. We can see, oh, hey, that's what we had to begin with. And that will work for this one up here as well, okay? That's it for today, and then just let me know if you have any questions when you come back to class.